this version of Etabs, because as long as this is failing in capacity is OS, it's overstressed. So let's go to design. Design concrete frame. um View and preferences. Okay, so we need to check these columns. So let me go back to define. Let's unlock the model. We need to know which define. Go to properties. We need to go to property frames. I need to know the types of columns I have. So modify. Have these columns, that is T16 4 corner bars and 2 intermediate, T16 and T8 at 200, as we have used in this affordable T8 at 200 links. This is probably by government of Kenya, so we are going to use it as our reference. We're going to use a suggestion from Structure as our reference, and this manual design from an engineer, another engineer, as our reference. So okay, we have that type of column. I have this type of column. It's just the orientation has changed, but it is more or less the same things uh, in terms of rebus size. And I have this another column here. Now this one, let me change this one to T20. So we need 4 T20 and 4 T20 corner bars, right? So then 2 T20 intermediate. Okay. So this column, so let's run the analysis and then run the design. We see if the columns are still going to be overstressed. If they are overstressed, we change them to non-sway, because obviously these columns are not sway, they are non-sway, because as long as they are braced, they are not sway. So let's run the design, concrete design. So I know these columns are non-sway because I was there in construction. As you can see here in this drawing, the rendered view, from the rendered view for these, you can see we have masonry walls. So these obviously they are braced, so they are not sway. I'll go back to page 46. Obviously, we have seen for the most critical columns, we were using 6 T20s. So there's no need to, but we just confirm up from the foundation level, the ground floor level, and the first floor, we use 6 T20. And there is also these columns which were passing at 6 T16 from the foundation level. But the size is obviously 400 by 200, 400 by 200, as I've modeled in both Prota and Etabs. You can see 400 by 200, right? Now these columns are overstressed, right? So let me overwrite. So this column is new, the column with 40 T20s. So let me overwrite, and let's say it's a non-sway. It is still overstressed. Okay. Overstressed. Even those all reds, just select them, overwrite, frame time, non-sway. Okay. So for all those overstressed column, I'll select them. So this column is not overstressed. Let me see. This is not overstressed. This column here is not overstressed, but that column is overstressed, and this one is also overstressed. So override non-sway. All columns are non-sway. Override non-sway. Override non-sway. So change the non-sway moment 0.7. 0.7. Still it is overstressed. Then so I'll select all these columns and that. Then I will unlock the model, assign section properties. I'll assign that. That is new. So I can just select this, right click, show selected objects only, and then from here escape, select object types, column, right click, okay, then run the analysis. Run the design. If that fails, we are going to change the grade of steel, because obviously I know from the site we used grade 500 of steel, but here the default value in Etabs is not grade 500. So I'm sure that could also lead to that overstressed warning. Okay, now how many are remaining? These two are passed. This one is still overstressed. This one is still overstressed. Okay. Let's go to settings, rebar. Okay. Let's go to analysis. Building analysis. So here we're using grade 500. You can see the reinforcement, steel grade, edit material. So we can copy these values, this value of steel grade. Okay, we can copy them to Etabs. So I will unlock this model. Then I'll go to define. I'll define materials. I'll define rebar, modify show properties. Okay, Now instead I will use these values. Modulus of elasticity is 200,000. Shear modulus is 79,434. Modulus of elasticity is 200,000. Okay, 200,000. Coefficient of thermal expansion thermal is 0.000. Can we copy this value? Copy. Paste that value and just move that. Weight per unit volume. Weight per unit volume is that that is shear modulus Newton per millimeter squared. Let's see. Material tensile strength. Let's see a few. Tensile strength, Newton per millimeter. This one is in MPa. That is Fy. So this one, can I change this one to 500? Because I think MPa, convert MPa to this value. MPa to Newton per millimeter squared. Let's change the value. MPa to Newton per millimeter squared. So 1 megapascal is equals to 1 Newton per millimeter squared. If you check on your Google, can just check on Google. So it means that this value here is this value here. Okay. Okay. So this one can also change to about expected yield strength should be a bit more, maybe 520. And then okay, then advanced data, do you need this bearing? Okay, material dumping ratio, do you have that? No. Okay. So that is what I used. Let's now redo analysis. So that is the material we used in this affordable housing project. Now all members are not overstressed, but we need 60-20. This is evidence enough that this proves that The extra dead load on slab should be a value of 2, because that is what these particular engineers used. If I change this value to 460 for columns, then analyze, start. So I'm going to go with the value for item. So I think every time you are designing, don't under design, don't underload your slab. The value should be not less than 2.5 extra dead load on slab. Thanks for watching. See you in my next video.